This is Algebra 1, Unit 4, Lesson 4, Line of Best Fit. Hopefully you were able to attend our Zoom classes this week in going over this lesson. If you missed it, I thought I would do a quick recap of what you missed so you're able to try the practice problems. So the first thing we talk about is a scatter plot. And what a scatter plot is just graphing points. So right here it says it's a two-dimensional graph. We know what x and y is of two quantities. That's our x and y. So you're looking for a relationship between the x and y values. And you can see right here, this one has a relationship. You can almost see a line developing there, and that's what we're looking for. If you don't see a line, something like this, that's saying there is no relationship between the x and y. You graphed all those x's and y's, and there is no linear. We're looking for a line relationship between the data. All right. So if we were in class, I would ask you to graph these data points, and then we would talk about them. But just to save time, it's already graphed for us. So what they're graphing are x values, are the temperatures, and they have it in Celsius, and the y values are the sales of ice cream in dollars. So over here is the temperature, the x value, and then the y value are ice cream sales in dollars. So you can see as the temperature increases, the sales of the ice cream also increases. And you can see again a line forming. And we're just going to put a line in there as best we can. It's called the line of best fit. Okay, so here they put one in there for us. And you want to get it as close to those data points as you can. So our job is to get that line as close as possible to all the points. And you try to have as many above as you do below. So this is a pretty good line of best fit. There's no perfect, but this one's pretty close. All right. So what we're looking for is a correlation between the points, or they call it a relationship here. This one has a positive relationship or a positive correlation. This one has a negative. You can see it's going downhill. It's just like our slope going left to right. Our slope's going uphill, so this one's going positive. This one, the slope's going downhill, so it's a negative. Sometimes there is no correlation between the x and the y, and that would be this third case. They said there is no relationship between the x data and the y data. So this is what you'll see in Schoology. They'll graph some data points for you and ask you questions. So the first question says, we're comparing the number of hours Jim worked to how much money he made. So the first question asks, how many dollars did Jim earn for working 5 hours? So we're going to estimate, here's the 5 hours he worked. We're going to go up there, and it looks like right there. So it looks like he earned about $48. All of the questions in Schoology are multiple choice, so you don't have to be exact. So he earned about $48 for working 5 hours. Okay, they're saying use that line that they have drawn for us to predict how many dollars Jim will earn if he works 10 hours. So we're going to go over to 10. See, he hasn't worked 10 hours yet, but we're going to predict. And we're just going to, as best we can, estimate. And it looks like right there, it looks like he's going to earn about $72 if he works 10 hours. Is the slope of your line positive or negative? So again, we always look left to right. So it looks like it's going uphill. The more hours he works, the more money he earns. So we're going to say this has a positive slope. All right. And the last question, according to the line of fit, when Jim's hours increase by 5 hours, how much do his earnings increase? And what I found interesting about this graph, as you can see, Jim starts, his y-intercept is right here at 24. That means if Jim works 0 hours, he still earns $24. So I guess he gets $24 just for walking in the door. So the question is, if he earns 5 hours, how much more? Not how much is he earning at 5 hours, but how much more? So we're going to go from 0 to 5. And we're going to see how much more he earned. So it looks like he started at $24. and it looks like he went up to $48. So we're going to take 48 minus 24, and to answer their question, it looks like he increased by $24. All right, here we go. Here's a bicyclist, and he starts off, it looks at about 170 kilometers. And as he rides his bike, as time increases in hours, the number of miles he has left on his bike ride decrease. So right away you can see this is going downhill. Number of miles left is decreasing, so it has a negative slope. So they're going to ask us which line best represents this line of best fit. So the first thing I would do is get rid of the positive slopes. So we know it's not B because that's a positive slope. We know it's not D because that's a positive slope. Then I want to estimate what my slope is going to be. So I'm just going to randomly pick 2 points that look like they hit on the grid marks here. And I'm going to estimate what my slope should be. It's not going to be perfect, but we'll be close. So it looks like we're going from 160 down to 120. So it looks like we're decreasing by 40. And then we're going to turn the corner, and it looks like there's our by 0.5. Every grid mark is a half. So it looks like that's a half, that's 1, that's 1.5, or 1.5. So our rise is a negative 40, and our run is 1.5. Let's get rid of that decimal. So if we get rid of it on the top, the bottom, we're going to move it over here too. So it looks like our slope is about negative 400 over 15. And we can simplify that. 5 goes into each of those, but this one's a proper fraction. The numerator is smaller than the denominator. Ours is an improper fraction. So right away I know C has to be wrong too. So that leaves us with A. That's the closest we can get to an equation for that line. It starts off at 170 and it goes down 25 and over 1, looks like. All right, let's try another one. It says a small theme park is trying to determine the number of guests they should expect on a weekend based on the temperature. So our x-axis here is the temperature in Fahrenheit. Our y-axis are the number of guests in thousands that are going to attend the theme park. So the question is, if the temperature is about 80 degrees, how many guests do you think they're going to expect? So the first thing I'm going to do, it doesn't go quite up to 80, so I'm going to just extend our line as best I can. There we go, that works. Then I'm going to go to 80, and I'm going to see what approximately I think they should expect. And boom, it's right there. So it's right around the 8. Okay. Do they expect 8 people that weekend? Heck no, we know it that 8's not really. Move that back over. We know that 8 represents per 1,000 or number of 1,000. So we know 8's wrong. And we know 7,000 is a little too low. We know 9,000 is a little too high. So I'm going to go with, why do I keep grabbing this? I'm going to go with answer A. I think it's going to be about 8,300 guests that will attend the theme park that weekend. So the answer is A. All right, I think that covers everything you're going to see in Schoology. Please go to Schoology Unit 4, Lesson 4, and try the multiple choice questions. If you have any questions, just give me an email. Thank you. Happy Thanksgiving to everybody.